Good evening, students. Pushis are back after a small break to discuss the relative velocity concept, and that is lecture number 3, crossing river with minimum time and minimum depth. In lecture number 2, I discussed the crossing the river with uh, smallest distance, that means direct opposite point, crossing between direct opposite points. And also in lecture 2, I discussed the work done by the person. Okay, now lecture 3, very important for us. Two things I am going to discuss here: crossing the river in minimum time and with minimum depth. What's the minimum time? Let us see. This is the river. O is the point on one side of the river bank. P is the point on the direct opposite to the point O on the other side of the river bank. Man wants to cross the river in the smallest time. So how will he swim? Okay. Just I give an example of the train as in lecture 1. Suppose I ask you to go to travel along the width of the train in the smallest time. You can take 2 steps per second. So what will you choose? You will choose just the perpendicular distance between the two sides. That is the minimum width of the train. To travel along that 2 steps per second. That's it. So that you will be reaching the direct opposite point of the train in smallest time. And river is something like that only. River is the train surface. And this, if you are placing yourself on the river, you will find that river is not, water is not moving. If you are swimming on, if you are floating on the river, you will see that river is not moving. Only the river bank is moving in opposite direction. But you want to cross the river in the minimum time. So river width is D. So you should cross over the perpendicular distance between the 2 points of the river width. If you want to cross the river width in the smallest time, then choose the perpendicular distance between the river width and aim your body along that line and swim. So it will be, because velocity of the swimmer with respect to river water same in all possible directions you choose, just like your walking speed is same in all possible direction in the train with respect to train surface. So if you choose the smallest distance OP with respect to the river, then and choose your velocity along OP only, so you will get the smallest time. That's what I have explained here. The swimmer has to cross the river in minimum possible time. So you know from lecture 2, that's what I'm saying, that the time of crossing the river is T is either SMW by VMW magnitude, or SWG magnitude by VWG magnitude, or SMG magnitude by VMG magnitude. All the three will give the same time. But among them, the VMW is fixed. That is the velocity of man with respect to water, that is swimming speed, is fixed in all possible direction. Same in all direction, that is V. V, we know this common notation is V. So time will be SMW magnitude by V. If I want to minimize the time T, then V I cannot do anything because V is a constant for a swimmer. SMW has to be minimized. SMW means the displacement of the man with respect to river water. And with respect to river surface, the displacement has to be minimized. That means that is this distance only with respect to the river surface. If man is swimming, he will see that this river is not, water is not moving. So this is the smallest distance OP. That has to be the minimum value of SMW will be D only. So that's what, in other words, if the man swims the smallest distance on the river water surface to cross the river, it will take the smallest time. That's it. If this is smallest, then time will be smallest. The smallest distance on the river surface, on the water surface, to cross the river is river width D only, as you can see. What is the smallest distance on the river surface to cross it? That is the width of the river, D. So see the figure. Again, I'm showing the figure. This the smallest distance on the river water, on the water surface, so that the man will cross over the river is OP distance only from here to. As the man swims, this O and P will move back only, but this perpendicular distance is smallest distance. That is remains D only. Okay. So the smallest distance will be SMW, smallest distance will D. So T minimum will be D by D. That is equation 2. When the man swims, keeping his body oriented along D. The man will reach the opposite bank, not at point P, of course not, because as I told you, if man is swimming like this, then this river bank will be moving direct to him backward direction, somewhere on some point B or whatever that point may be. You will not reach the direct opposite point on the river bank. With respect to ground, it will not reach the direct opposite point. So it will reach somewhere in B with respect to ground. B is the landing point. Obviously, it is traveling more distance compared to the case 1 in lecture 2. So this P to B distance, the direct opposite point on the river bank is P and the landing point is B. The P to B distance is the drift. Okay, that is SWG magnitude. Okay, so that's it. So then this SMW plus SWG is SMG. See the vector diagram. SMW is this man with respect to water, travel like this. SWG is the man's body which is drifted down due to the water stream velocity, and the man's displacement with respect to ground will be O to B. So OP bar plus PB bar will be OB bar. That is SMW bar plus SWG bar is SMG bar. Okay, so this is what we have seen. That's what I wrote here. Okay, SMW bar plus SWG bar, that is SMG bar. So, and what is perpendicular here? SMW is perpendicular to SWG. You can see this diagram. This is perpendicular. SMW perpendicular to SWG. That means the VMW is perpendicular to VWG. So, understood this? So, man's swimming velocity direction, and which is along the width of the river, and the river length, that is river velocity direction, they are mutually perpendicular. I can write like this. Okay. This is clear to all of you? Right. Okay. So what is PB distance? The drift, how much it is drifting down? PB distance is D, and PB distance is how much? This PB distance, that is VWG distance into time T. That's what VWG magnitude, sorry, VWG magnitude into time T. So this PB distance is VWG magnitude, SWG, that is VWG magnitude into time T. VWG is U. So VWG this VWG magnitude into T, and that is the minimum time. So U into D by D. So U by V into D is the PB. This is the drift. This is the drift. In this case, we call it as drift. Okay. So then I am asking you, which normally you don't do, work done in crossing the river in minimum time. How much? Refer to lecture 2. Drag force into SMW. SMW is simply D. Velocity with respect to, displacement of the man with respect to water. With respect to water is going in this manner only. So D is the displacement with respect to water. So that's SMW magnitude. F drag is the work done by the man in crossing the river. Work done by the friction. Drag force will be negative of this. So F drag into D. That's it. That's equation 4. Actually, the work done in crossing the river is minimum only when the time taken is minimum. Okay. I have elaborately discussed in lecture 2. Lecture 2 must go through again and again. Okay. So now the second point, we are crossing the river with minimum drift. We know from the lecture 2 that if VMW is less than VWG, that means the swimming speed is less than river water speed, that V is less than U, the swimmer can never reach the direct opposite point. Yes or no? Only by swimming he cannot reach from O to P. ये O to P वो कभी भी by swimming से पहुंच नहीं सकता, क्योंकि वो ट्रायंगल बनेगा नहीं कि resultant velocity will be along this direction. नहीं बन पाएगा, क्योंकि this if VMW is less than VWG, then this cannot be as the this length. The resultant can never be along OP. We have discussed in lecture 2. Yes or no? So definitely land somewhere downstream. So definitely land somewhere at the downstream, some point B which is downstream. So direct opposite point P he cannot reach. So he will land up at some point B downstream. The distance between direct opposite point P and the landing point B, that is PB, is known as drift. How to minimize the drift? Just see. This is the new diagram. So this is my, I draw a line OC represents my river water velocity, VWG, magnitude is U. And VMW, as you know, he can swim in all directions the same velocity with respect to water, same speed with respect to water. I draw a semicircle whose radius represents the VMW. So that VWG vector is greater than VMW vector magnitude. So obviously the semicircle looked something like this. So all the points C to D, D is the any point on the circumference of the semicircle, OD, 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 they are all possible VMW. Man, depending on the man's wish, he can choose, he can orient his body along any of the ODs. Okay, then the VWG plus VMW will be VMG. So the OD will be VMG. Okay, are you understanding this? OC is VWG, CD is VMW, vector sum of these two will be VMG. So VMG will be all the point OD. If it goes like this, his MC's body like this, then OD will be VMG will be like this, and he will be landing somewhere very far away, cannot show in the diagram also, maybe 100 kilometers away from the direct point. Okay, but he has to minimize the drift. Drift means distance PB, P to landing point. He has to minimize the distance between P and B. What should he do? So he should choose such a direction of his VMW that OD will be closest to OP. That means OD should be tangent to the semicircle. Understood this or not? The OB should be closest to OP means this, and it has to be cut the semicircle. So it should be tangent to the semicircle is the limit. So this, if he aims like this, so that VMG will be like this. VMG will be perpendicular to VMW in that case. So for the minimum drift, this is the direction he should choose. This is the, VMW should be like this. So this body has to move like this. Any other VMW chooses, the body will landing beyond B. Okay. So the closest point to P where he can land will be when this OD vector will be tangent to the semicircle. That's the graphical way of solving this. We have solved this in our, similarly we have done this, if you remember, the maximum deflection of particles in elastic collisions. We have used similar concept. You go through, I have discussed this, you go through my videos, lectures on deflection of the in oblique collision, the maximum deflection of particle colliding. Okay. So now OD should be tangent to the semicircle for minimum drift. So then if this is the case, this is OD, or this is MW. I can write the same MW here also, VMW parallel to this. So this is V, this is VWG, this is VMW. Resultant will be just construct the resultant. This will be OD, will be the VMG for the minimum drift. Okay, with theta kya hai? What is this theta? Some angle we have to find out. Okay, since it is 90 degree, cos theta will be VMW magnitude by VWG magnitude, as V by U. So cos theta is V by U. Understood this? This you can remember. So this cos theta is V by U. Cos theta is V by U. This theta, this is theta, this theta. Okay. So cos theta is V by U. So OE is equal to also VMW, because OE is what? That is OE is parallel to CD. So that is OE. So that is VMW only. That's what I'm writing. This is just I'm giving you for the easy reference. So OE is equal to VMW for a minimum drift. So man must aim to the point A along OE. So if he wants to go to the land at the smallest distance, or he wants to minimize the drift, then he should orient his body like this. He must orient his body like this and start swimming, and his body will be moving along VMW like this. He will be aiming to OA, and body will be moving like this and landing at B. Understood this? So this is for the minimum drift. AB is the SWG with respect to water. This is VSW. This OA will be VSMW, AB will be SWG, and OB will be SMG. So this is VMW into time. This is VWG, that is U into time, and this is VMG into time, OB. So, but minimum drift will be P to B value. You have to find out from geometry now. This is D. This theta, already cos theta, you know, V by U. So PB minimum, that is minimum drift will be PB, which will be D tan theta from this diagram. So like this, you can easily find this. That's what I wrote. So minimum drift is, when the minimum drift, what is perpendicular to what? See the diagram, minimum drift, PMW and VMG, they will be mutually perpendicular. You see this tangent is perpendicular to the radius. So VMW and VMG is perpendicular. So this is VMW and VMG is perpendicular. The swimming velocity and the velocity with respect to ground will be mutually perpendicular. That's what I wrote. Time for crossing. Time for crossing, very simple. OA, that is SMW divided by VMW. That is OA by small b. OA is how much? D by sin theta. D by sin theta by small b. So OA is D by sin theta, that is VMW magnitude is V. So D by V sin theta. That is the time for crossing. Minimum PB value is D tan theta. Just I told you earlier. So D, and this is theta. So tan theta is PB. D tan theta is PB. That's it. Work done by the swimmer to cross the river. I told you earlier in the lecture 2. F drag into SMW. Drag force into a relative displacement. So drag force is always opposite to relative displacement. So your work done will be positive. Friction work done will be, drag force work done will be negative. So your work done will be F drag into SMW. SMW is D by sin theta. So that's what? F drag into D by sin theta. That is the work done. So here, note, I made a point here. In lecture 2 also I discussed the identical thing. Work done to cross a river is minimum when the time taken to cross over is minimum. Okay. Example लेते हैं. Swimming speed मान लो 3 km per hour, that is V. River water speed, reverse water speed is 5 km per hour. So obviously cannot reach the direct opposite point because V is less than U. Find the minimum drift then and the time as well as work done to cross the river. If F drag is 25 Newton and river width is D is 200 meters. This 25 Newton F drag I gave in lecture 2 also. This something like 22-29 Newton. I am giving some average value. So cos theta is V by U, as you know all. Yes. Cos theta is, this is the V, swimming velocity with respect to water, mass, and this is U, water velocity, VWG. So cos theta is, this is 90, this is tangent mean, this is 90. So in this triangle you can see, so this cos theta is VMW by VWG magnitude, so that is V by U. So cos theta is V by U. पहले लिख दो भाई, ये 3 km per hour, 5 km per hour. So 3 by 5 हो गया. So theta is 53 degree, 180 minus 127 degree. So man must aim at an angle 127 degree with river water velocity. His body should aim at this angle. Okay, so sin theta will be 4 by 5, tan theta will be 4 by 3. So theta में लिख दिया. So minimum drift d tan theta already I have found out. Where minimum drift? Minimum drift is d sin theta, equation 6. Use this. D tan theta, equation 6. So that is 200 meters. Tan theta is 4 by 3. So 800 by 3 meters. At 267 meters will be the minimum drift. Any other orientation his body swims, it will be more than this. So work done in crossing the river. कितना होगा भाई? I told you F drag into SMW, that is d by sin theta. So 25 into 2d by sin theta is 4 by 5. The cos theta is 3 by 5. So this becomes 25 into 1000 by 4, 250. 25 by 250 is 6250 joules, 6.25 kilojoules. Quite a bit of work. Time कितना होगा? The same thing. The SMW magnitude by VMW magnitude. SMW magnitude is OA divided by SMW magnitude divided by VMW magnitude. That is d by sin theta divided by small b. So time taken is d by sin theta divided by small b. 200. Yes, sin theta denominator is 4 by 5. V is 3 km meter per second, 3 by 3.6. This is 3 by divided by 3.6 to make it meter per second. So 200 by 3 by 3.6 by 4 by 5. So ये 1000 by 250 by 3 by 3.6, that is 250 into 1.2, that is 300 seconds. So 5 minutes it will take. Yes, sir. So it will, for minimum drift condition, it has to swim for 5 minutes at an angle 127 degree with respect to the river water velocity. His body should orient, he should aim like that. And the minimum drift will be 267 meters at 800 by 3 meters. That's it, all questions answered. क्या लिखा मैं extra point में? The swimmer crosses the river. If the swimmer crosses the river in minimum time, instead of for minimum drift, work done by him will be minimum. That will be V drag into displacement with respect to water. That will be for minimum time will be D only. F drag into D. So 25 into 200, 5000 joules. Instead of 6250 joules, it is 5 kilojoules, 5000 joules. Okay, and time also will be, you must be knowing, that is D by V. Already I discussed for the minimum time. That will be 200 by 3 by 3.6, 200 by 3 by 3.6. That is 240 seconds, 4 minutes. So minimum time will be 4 minutes if he wants to choose minimum time. And the work done also will be minimum 5000 joules. But the drift will be much more than 800 by 3 meters. Yes or no? That's it. How did you like this? Just go through my lecture again and again. I think if you are know this graphical method, you don't have to do many calculus and all this, which people have solved in various calculus method. Let this be the, then differentiate, make theta is the to find the minimum theta, for find the theta for making the drift minimum. Nothing is required, just draw this u vector, take the v is less than that, so draw a semicircle and draw a tangent to that. Radius will be vmw, this is u, and the tangent will be vmg. That's it, the extended tangent, that distance is the minimum drift. So let me write here as the minimum drift. So drift minimum from where to where? Here to here. Yes or no? That is because this tangent is extended to cross the river bank at B. Right? I think your exams have gone well, or the upcoming exams you are feeling more confident now. Okay. Now put your best effort. Have enough time. Sky will not fall if you have done anything slightly badly in the exam. You can always rebound. You can spring back to match the next exam. Understood this? Never lose faith in yourself. Put effort. Doing a exam badly doesn't mean anything. Well, you should increase your confidence more and more by solving more and more questions, by making more and more practice, by clarifying your concept. Anyway, my credentials, you can talk to me, you can reach out to me in case you have any conceptual difficulty on whatever topics I'm discussing. If you are following this, now I don't think river water problem will pose any problem for you. Most of the problems you can be, I am not saying all the problems you can solve, but most of the problems which are generally asked, you can solve. Don't worry, we will be meeting very soon with new topics, and I'll see what other topics you are not responding with, anything regarding your requirements. If the moment you say something, you go through the video, recommend to others, subscribe to the channel so that you will get information when I upload anything, and you can reach out to me also. This I'm giving, we will fix a time, mutually agreeable time, so that we can discuss more. Thank you all the best. Don't worry, you will do well. Thank you.